Hi everyone, I'm Rishab, and today I'll be discussing generating analytic specifications for data visualization from natural language queries using large language models. This work was done in collaboration with folks from the UNC Charlotte and Georgia Tech Viz Lab. So there have been a growing number of systems in the natural language to visualization, or NL2Viz field, where users can generate visualization simply by inputting a natural language query and an associated dataset. The given NL2Viz systems here utilize semantic parsing and rules-based systems to do such a task. Let's look at one such parsing-based NL2Viz system, NL4DV. Consider a dataset on movies and natural language query. Show the relationship between budget and IMDb rating for action and adventure movies that grossed over $100 million. Now, what NL4DV does is it extracts data attributes, infers analytic tasks, and recommends relevant visualizations, all modeled into a JSON object. This JSON affords explainability to the user. However, because it's parsing based, NL4DV is only limited to supporting certain query types and structures. Enter LLMs, which cause a sizable growth in available NL2Viz systems, with 3 appearing just in the past year: Lida, ChartGPT, and Chat2Viz. These systems have shown to have comparable performance and accuracy and even outperform previous NL2Viz systems. They can also support way more query structures compared to rules-based systems like NL4DV. And if we take a closer look at the prompts behind these LLM-based systems, you see that it only takes a paragraph or so to actually create a functional NL2Viz system. As you see here with Lida and Chat2Viz, you see that they basically ask the LLM to generate code that displays visualizations. But unfortunately, because these prompts are so brief, they heavily rely on the design knowledge that LLMs have learned in their training. There's essentially limited explainability in their outputs compared to parsing-based NL2Viz systems. So can we get the best of both worlds and create a system that has the same expressiveness as LLM-based systems while maintaining the explainability of parsing-based systems? So to enhance the explainability and debuggability of previous LLM-based NL2Viz systems, we use NL4DV's architecture as a template to develop a new prompt, NL4DV LLM, which supports all the essential components of NL4DV and also creates an output JSON just like NL4DV's. And here I'm showing the prompt as driving all the previous architecture diagram. And as you see here, the prompt is very large and comprehensive, which is needed to support NL4DV's architecture. This prompt consists of definitions and instructions for detecting analytic tasks and attributes, and in turn to generate visualizations. So now let's take a closer look at a couple comparisons in response between NL4DV and NL4DV LLM. If we look at the top query here, we see that NL4DV failed to detect the latter part of the query, 1996 to 2009. However, NL4DV LLM was able to detect this and display it in its visualization. Perhaps this query kind of exists outside the syntactic rules in NL4DV's programming, which shows potential restrictions that parsing-based systems have. Now, if we look at the bottom query here, NL4DV was able to infer the implied task of derived value of average. However, NL4DV LLM does not make that same inference, and instead only extracts one data point for each given year and creates a line chart from it. So a user might not be able to get their query intent from NL4DV LLMs compared to NL4DVs. So to further examine the performance of NL4DV LLM and NL4DV, we conducted an initial evaluation of the systems on NLV corpus. We primarily looked at accuracy as our main metric, which we define as matching the NL query's intent and containing all the potential attributes, tasks, and visualization types requested for by the query. So here's our initial evaluation results on about 700 queries from NLV corpus. We see that the prompt had a much higher accuracy than NL4DV, basically a 23% increase in accuracy. However, the average response time for NL4DV was around 3 seconds for each query, compared to NL4DV LLM's average response time of 25 seconds. So there might be a trade-off between accuracy and response time based on this. In terms of qualitative metrics, we found NL4DV LLM was more expressive than NL4DV, which meant that it was able to support a wider variety of query forms and structures. However, NL4DV was more consistent in its responses compared to NL4DV LLM. NL4DV LLM would randomly fail to produce visualizations for the most basic queries, like correlate budget and gross. And sometimes it would also hallucinate attributes that weren't a part of the dataset as well. Thus, both systems seem to have their strengths and trade-offs. But for now, I'm excited to share that the prompt is now a part of NL4DV's new LLM base mode and is available to view on GitHub. I've also attached a code snippet for you to view how to utilize our prompt. Check it out. Thank you.